another awesome video. I wasn't going to make a video for this activity, but I've had several requests, and if the crowd needs another awesome video, well, here we go. Okay, so we're going to program this little spreadsheet to do as much of the math as it can for us, and it's all pretty straightforward math. We just got to keep our heads clear as we go through and fill this out. So first and foremost, the sponge has length and width. That is to say, it has a certain area, surface area. And the surface area, well, the surface area is equal to the length times the width. Return. Okay? So if I have a sponge that's 4 by 3, I fill those in, boom, it's 12. Okay, so good. So that's how you do that one. Now what's not going to change is the surface area of your sponge. So let's go ahead and say that this one is equal to this one. Okay, because that won't change even when you squish it. It'll still be, if it was 4 by 3, it'll still be 4 by 3. So I'll hit enter. I'm going to go back and choose that cell, and I want, same story with these two. I want those to fill also with the area, because later, for instance, when stress is done, it's going to do force divided by area. It's going to take this number, divide it by that number. And in this column, it's going to take force divided by area. So these have to be filled. These can't be blank. When trial 3 does force per area, it's going to divide force, whatever's here, divided by area, whatever's here. So that, these all have to have values in them. So make them equal to this, and then just drag it across. The height of the sponge we're going to fill, we're going to just measure that. In fact, I'll tell you right now, it's 1.75. All these sponges are 1.75 inches tall. Right? And I can click outside and click back on it, and I can drag that right over, and now they're all 1.75. The sponge will always start at 1.75 inches tall, and then when you squish it with different masses, it'll go to different, it'll get squished by different amounts. The weight on the sponge, we want that in pounds, but we're entering it in grams because all the weights we have are stamped in grams and all the rest. So we want this to be pounds, and right after we put in grams. So we're going to equal what? Well, we're going to equal the mass in grams, and we're going to multiply it by the conversion factor of 0.0022. So times 0.0022. Okay, I'm going to click outside, and I'm going to click back on it, and I could go through and do each of these individually, but I could also just drag that circle over, and I just programmed all those cells. For example, this one is this one times 0.0022, and this one is this one times 0.022, and this one will be this one times 0.0022. Okay, the stress is how the sponge is coping with the external pressures, and it's equal and opposite to the external pressures. And pressure, as you recall, I'm sure, is force divided by area. So the stress within the sponge is going to equal the force divided by the area. Enter. Now, don't worry about this error. It's just that right now we're having it divide by 0 because we don't have numbers in here. And you can't divide by 0. So it just says error, but as soon as numbers show up, that will not be an error. Now, again, I could go program the other cells. But I could also just drag this circle over, and I just programmed all of those. Okay. The new height we're going to put in, we're going to measure it. Oh, it was 1.75 inches tall. We put some number of grams on it, and now it has a new height. So it went from 1.75 down to 1.5. Well, then it would have got a 1/4 inch shorter. So what are we doing the change in height? What are we doing mathematically? Well, we're just taking the original height, and then we're subtracting the new height, right? And that's the change in the height. That's the change in the height, the original minus the new, and I just hit that. And again, I'm just going to drag this over to program these other cells with that same change in height, original height minus new height. And then the strain is proportionally how much smaller it got, really. So this is change in length over original length. This is equal to the change in the height divided by the original height. Okay, and then I'm going to program the other cells just like above and do that. We are done. We're done. Okay, that's the setup right there. Now I just want to demo this. Right, you're ready to go collect data right now, but I'm just going to do a fictitious little setup here. I'm going to say I have that 4-inch by 3-inch sponge. Boom, it fills out all the areas as 12 square inches. Okay, and then here I'm just going to pretend I put, I don't know, 1,500 grams on the sponge, and it tells me that 1,500 grams is 3.3 pounds. Okay. Now the stress within the sponge is force divided by area. So 3.3 divided by 12 is about 0.28. There's about 0.28 pounds on every square inch of that sponge. That's the stress. That's the pressure. And the sponge is pushing back with 0.28 psi. That's the stress. Okay. The new height, well, let's say when I put this 3.3 pounds on it, it went from 1.75 down to 1.5 inches. So this change in height will turn to 0.25. It got 1.75 minus 1.5. It shrank by 1/4 of an inch, right? Which means that it also got 14% smaller. 0.1, it is 0.14 smaller than it was before. It's 14% shorter. That is to say, 0.25 is 14% of 1.75. Okay, so and then you go fill out the others as well. So this is fictitious. This is fictitious. I just made that up, right? And these numbers up here, I just made up. We're back to where we're starting, which is right here. And this sheet is now ready for you to go collect data. Okay. I hope you enjoyed the video. It was a blast to make, and I will talk to you soon. Roger Dodger over and out.